Hi and welcome to today's video, which is just going to be a quick introduction to metallic bonding. So I've done some videos that look at ionic bonding and covalent bonding as well, which might be useful to have a look at. But the definition of metallic bond is it's a bond between metal atoms where there is a sea of free valence electrons. Now, if you've had a look at the video on ionic bonding, you would know that an ionic bond occurs between a metal and a non-metal atom where they exchange valence electrons. So the valence electron in the metal goes all the way over to the non-metal and they form a bond that way. A covalent bond between two non-metal atoms is where they overlap their electron shells and get their full outer shells that way. Now, when you've got a metallic bond between two metal atoms, they don't want to accept electrons. Metals always want to donate electrons. And so what that means is that instead of getting like this overlap of electrons or this exchange of electrons, what actually happens is that the metal atoms come close together and they form, very similar to where you looked at an ionic substance, they have a lattice. So you get these metal atoms which come in together, all right? They're all positively charged, so they're cations. So you get these metal atoms which come in together like this. However, obviously because these are all cations, they're all positively charged, these would repel each other. So what actually happens is that inside the lattice here, this three-dimensional metallic lattice that we've actually got these free valence electrons. So instead of being formed into bonds, right, the valence electrons actually sit in between all the metal cations. Now this is what we call a free sea of valence electrons. Right? These electrons are free to move between the metal atoms, and the very strong electrostatic attraction between the metal cations and the electrons actually make this into a very strong structure. Okay? Now, this has a number of impacts upon the properties of metallic substances. Because there are a lot of atoms in a space, and because you've got a strong attraction between the cations and the electrons, they have very strong bonds. And so what that means is that this will result in a substance which has a high melting point, requires a lot of energy to break apart the electrostatic attraction between the cations and the electrons. Okay? So metals have high melting points, which is not surprising. Because you've also got electrons which are free to move, that means that metals are very good conductors of electricity. Because when you supply an electric current at one end, electric current is basically just a flow of electrons. The electrons can pass through the metal and conduct it to the other end. So that makes them very, very good electrical conductors as well. Okay. When you melt metals, all right, again, because you've got the cations there, because you've got ions that are formed in the molten state, metals are good conductors of electricity in the molten state as well. So this free sea of valence electrons is really, really important for metals. It gives them high melting points, it allows them to conduct electricity, okay, and it makes them quite strong and hard, okay. So the definition of a metallic bond is where you've got metal atoms here, all right, where there is a free sea of valence electrons. Sometimes you'll hear these referred to as well as something called delocalized electrons. And what that means is they're not in one spot, so they've been delocalized. They've been moved so that they're free to move throughout the structure of the metal here. All right, so that's what a metallic bond is. Hopefully that's been fairly straightforward for you. The key to understanding the real properties of metals is due to the fact of these free valence electrons, this sea of electrons which can move between the cations, which allows for very strong electrostatic attraction, which means that they have high melting points and they're good conductors of electricity in the solid and molten state. All right, hope this has been helpful for you, and as always, if you've got any questions, just ask. Thanks, guys.